Alright folks, this is Mr. Kim. Today we're going to learn about pattern and expression, which is our chapter 10 of the textbook. But we're going to specifically talk about describing a number pattern. So, please prepare your class note. And let's write down our title first. Yesterday we talked about basically describing any type of pattern when it comes to any shapes or structure. But as a quick recap, let's write this. When it comes to pattern, if I describe it in a very easy way, pattern is basically an arrangement, but specifically a predictable arrangement. It is a predictable arrangement. So, yesterday, what we look for is, for example, the pattern of, let's say, I have one square. If I fold it in half, I have two rectangles. If I fold it one more time, I have four square rectangle. In this case, it is an example that I created. Technically, rectangle and square is different, but you may get the idea. It's just how many divided sections exist. So in a way that it's very distinct pattern, and you may expect what comes next too, even if you didn't know or you didn't actually fold the paper. Now, when it comes to today's lesson, it is about number pattern. So, let's describe a pattern by undergoing two of the classroom examples, shall we? So, class example. Classic example. Number 1. Basically, I want you to identify the pattern and explain. I want you to write this down. And when it comes to teachers, feel free pausing the video so that students can finish writing each of the given sentences or questions. I want you to put 3 of our fraction. 1/9, 2/9, and 3/9. I want everybody to take out their calculator, pause this video, and I want you to find a decimal form of those. Make sure you need to use calculator and use numerator divided by denominator. Go. Now, if you punch these numbers in, you may notice that the first number is repeating 0.111 and keep going like that. Second number, 0.222, 0.333. I want you to pause this video and I want you to, I want students to explain what's the pattern and I want them to write down in the sentence. Go. One of the example answer that we can find from this conclusion is there is a little bit of a correlations happening when you look at repeating decimal and the fraction. You may notice that repeating decimal or repeating digit is a numerator. That is one of the pattern that we can describe from this number expression, and this is a arrangement that we can even predict the outcome. For example, at this point, everybody must know in the way that if we have, let's say, 8/9, we should know how to predict this digit or decimal will look like even without using a calculator. Pause this video and I want students to find out the answer of 8/9 without using calculator. Go. The answer is 0.8888 and repeat infinitely. So that means it's 0.8 repeating decimal digit as 8. Now, as our definition above, we know that when it comes to expression and pattern, especially when we talk about pattern, it should be expectable or predictable. Let's do one more. Class example 2. I want students to write down 3 fractions again. This time, it will look like these. Again, pause this video. Let them find out the decimal expression of these 3 fractions. Go. Now, in this situation, students should find that it should be 0.0111 repeat, which means 0.01 and 1 as a repeating decimal. Now, I want you to pause this video and let students write down their conclusion or explanation of what is the pattern that they found. Go. Now, if you find out, or if each student find out their conclusion or explanation of the pattern, please make sure whether they're on the right track or not by comparing with mine. The conclusion that's acceptable or explanation that is acceptable in this situation is repeating decimal is a numerator, but it has 0 in front. Or student can write down that whatever the numerator is a repeating digit instead of 10th, 100th place of the decimal. Which means I want everybody write this down and predict what will be the answer of 7/90 without using calculator. I want you to pause this video momentarily after the go. Go! Right. If the kids understand what's going on in here, they should get the conclusion that it's 0.07 and repeating decimal is 7. So as you may notice, using those two classroom examples, now we know that, again, even though the pattern in today's lesson may not involve any of a geological shape, however, we can still predict what's going on in this sequence of the numbers, and we should be able to predict what's the unknown number by identifying the pattern. Now, these are my classroom example for today. I want each of their students do homework question, which is textbook page 355, number 7, 8, 9, 10, and textbook page 356, number 12. Thank you very much. And you may stop this video. Thank you.